Hi everyone, this is lecture video 11, and the topic of this lecture is the section 3.5 in your course book, which is derivatives of trigonometric functions. I want to start this video by emphasizing that many phenomena of the nature are approximately periodic. For example, think of electromagnetic fields, heart rhythms, tides, and weather. In such natural events, the derivatives of sine and cosine functions play a key role in describing the periodic behavior of them. So in this section, we show how to differentiate the 6 basic trigonometric functions, which are sine x, cosine x, tangent x, cotangent x, secant x, and cosecant x, okay? So these are 6 basic trigonometric functions. So let's start with the derivation rule of the sine x. The derivative of sine x is cosine x. And here you can find the proof of it. For the time limitations, I will skip this proof for now, and I leave the proof here in your lecture notes. Maybe you may wonder how to prove it, and you can find the proof here. But what we are going to do is to apply this rule and try to solve more and more examples. Okay, so the first example about the derivation of trigonometric function sine x, we find derivatives of these functions in this example. Okay, start with this one. Y prime is, the first expression is a power function, so you derive the power function like this, minus derivative of sine function is given as the cosine function, okay? Its first derivative. And let's look at this one. Obviously, this function in part B is a product function. That's why we have to apply product rule, okay? This is a product function of 2 functions depending on x. That's why you will apply product rule, which goes like derivative of the first function. So derivative of e to the power x is e to the power x times the second function plus first function itself times the derivative of the second function. Derivative of it is cosine x, okay? The derivative of it is cosine x. So let's move to part C. Y prime is, this time we have a quotient function. So we need to apply quotient rule, which goes like f prime g minus f g prime divided by g squared, right? Okay, and the application, f is sine x and g is given as just x. Derivative of f is cosine x times the denominator function minus the function in the denominator stays the same times the derivative of the denominator function, and then square the denominator function like this. Okay, so I think we got how we derive sine function. Now the derivative of the cosine function, the rule is given in this box. The only difference between the derivative of sine and cosine is this extra minus sign in front for the derivative of the cosine function. So derivative of cosine is minus sine x. Let's apply this fact. Okay, we want to take the first derivative of the given functions. It goes like 5 is just a constant, it stays, times the derivative of the e to the power x function, its derivative d over dx e to the power x is itself, remember, and derivative of cosine function is minus sine x. Next, you see here a product. This is a product function. We need to apply product rule for it. The product rule goes like, okay, if you name this function as f and this function as g, the first derivative function, derivative of f is cosine x times the second function itself plus first function stays the same, then times the derivative of the second function, which is sine x. Okay, this is f prime, this is g, this is f, this is g prime. Let's move on. And here we are derivating a quotient function. That's why we will apply quotient rule, which goes like f prime g minus f g prime g squared. Okay, this is your f, derivative of cosine is what? Minus sine x times the denominator function as it is, minus cosine function stays the same this time. And now you need to derive this part. So derivative of sine x is cosine x function divided by the way, yes, we are dividing by the square of the denominator function. Okay, this is the first derivative of the given y. So let's move on. Here is a nice reminder for you about what is tangent x. It is sine x over cosine. Cotangent x is in fact 1 over tangent x, so it is cosine x over sine x. Secant x is 1 over cosine, and cosecant x is 1 over sine x. Now, we will look at the derivative rules for tangent, secant, cotangent, and cosecant functions. Derivative of the tangent function, the rule for it is secant square x, okay? And very similar rule applies for the cotangent, except this minus sign, and except writing secant square, you write cosecant square, okay? And now look at the derivative of the secant function. It is secant times tangent. And look at this part. Derivative of the cosecant function is minus the similar rule, like cosecant times cotangent. And if I add 2 more items that we have already covered to this box, which are sine x derivated as cosine x, and cosine x is derivated as minus sine x, then this box will be a complete one for the differentiation rules of the 6 basic trigonometric functions, okay? Like that. And I want you to notice that, just for a nice hint for you, all the functions starting with cotangent, cosecant, cosine has minus sign in their differentiation rules. And the other ones don't have that minus sign, okay? Let's start applying these rules together. You see several examples here. And let's solve 7th one, for example. Yeah. F prime x. F is a product rule, okay? And you need to apply product rule here. Derivative of sine is cosine x times the second function itself, plus first function stays the same. You need to put here the derivative of the tangent x, which is secant square x, okay? Which is secant square x. Okay, this gives you the first derivative function for f. Let's also compute 9. Okay, so y prime is given as, this is also another product for which you need to apply product rule to take the derivative. Look at the first function. Let's try to derive this function now. Okay, so we are doing f primes times g, f times g prime. This is the product rule where f is this part and g is this part. Let's go for it. Derivative of the second function is what? It is secant x times tangent x, okay? And derivative of the tangent is secant square x. Okay, this whole thing is written for the derivative of the first part, which we call as f, right? Times the g function. Here you can see it, secant x minus tangent x. And then plus, maybe I should use the color red for the derivative things. Okay, derivative of the secant, as I said, secant x times tangent x, plus derivative of the tangent function is secant square x. Okay, times g and plus. Now I am writing the f function as it is. Secant x plus tangent x, this is f times the derivative of the g function. Okay, derivative of secant is secant x times tangent x minus secant square x, which is the derivative of the tangent. So that's it. Where this is f prime, this is g, this is f, and this is g prime. And finally, we can solve 22 and stop there. Look at 22. ds over dt we want to compute. Okay, this is a quotient function now. That's why we will apply quotient rule like this, divided by g square. Okay, this is your f and this whole thing is your g. What is the derivative of f? The derivative of f is cosine t times the denominator function, which is 1 minus cosine t minus. Now f stays the same, sine t, times the derivative of the denominator function. What is it? Derivative of 1 is 0. Constants are gone while taking derivative. And you have minus derivative of cosine function, which is minus sine t, like this. And then you need to divide this whole thing with the derivative, with the square of the denominator function. Okay, this gives you the result. I won't simplify anything so that you can see later more clear as you study. Okay, I stop here. Thank you for your attention. See you in the next lecture video.